Hello, everyone, and welcome to today's Spud Smart Roundtable Series webinar. My name is Ashley Robinson, and I'm the editor of Spud Smart. Today, I'll be serving as your host for this webinar. Today's theme is using SWAT maps to grow the best potato crop. I'd like to take a minute to thank BASF and McCain for partnering with us on this Roundtable Series webinar. Today's presenters are Wes Anderson, who is a global fertility specialist with SWAT MAPS, and Evan MacDonald, who is a precision agriculture specialist at Cavendish Agri-Services. In today's webinar, you'll learn about the impacts topography and topsoil deaths have on potato production, the effect dry growing seasons can have on canopy coverage and root mass/tuber initiation, what zone management is in a field, and how to use SWAT maps to tailor planting rates/spacings, fertilizer applications, fungicide, and insecticide applications to your fields. During this presentation, you'll likely have some questions for our speakers. Please type these into the chat box at any time during the webinar, and we'll address them during the question and answer session after the presentations. Today's webinar is being recorded and will be made available at spudsmart.com following this live event. Our first presenter is Wes Anderson. Wes is a senior fertility specialist with Crop Pro Consulting based out of Beaumont, Alberta. He currently works with farm clients to enhance their fertility programs using SWAT map variable rate technology, as well as supports the rest of the Crop Pro staff and third-party agronomists around the world that are using SWAT maps, meaning he's also the global fertility specialist with SWAT maps. Wes grew up on a mixed farm near Theodore, Saskatchewan, and obtained his degree in agriculture from the University of Saskatchewan in 2001. Since then, he's worked in various agronomy roles in Alberta, Saskatchewan, and more recently in southern New South Wales, Australia. As a member of the Alberta Institute of Agrologists, Wes is passionate about using technology in agriculture to improve the economic viability and environmental sustainability of farms. He has a wife and 3 kids, which keep him busy in his spare time and graciously put up with his infatuation for agronomy. Take it away, please, Wes.
Great. Thank you, Ashley, and appreciate the opportunity to share a few things today with people involved in potato production. So I'm just going to start and set the stage for what SWAT maps are, or soil, water, and topography maps, because I'm assuming to pretty much everybody in the call, it's probably a new concept for managing all things agronomy. Really, a lot of the time, our goal is to create management zones for the purpose of fertility management. But I think Evan will share some good specific examples of how it can be used for really all things agronomy in a lot of cases. So first of all, I'll just start with what causes variability, right? And I think if everybody in the call got together and we all put our minds together, we could probably think of a list much larger than this. But these are common things that we find in Western Canada and no doubt in other areas of the world. But there's a lot of things that ultimately affect the yield variability across a field, and likely NDVI or different imagery that we might be able to get in season as well. So insects, diseases, all those typical pests in all different crops can affect those things. Things like compaction, even 1 year oopses like spray drift, or maybe issues with the planter that affects plant population. There's a lot of different things. And with SWAT maps, we try and focus on the stable soil and water properties that really don't change necessarily from year to year. Now, relative water is dynamic. You can have wet years, you can have dry years. But across a landscape, there will be parts of a field that are always the driest, and there will be parts of the field that are always the wettest. Now, you might have temporal variability, shift those relative values up and down from year to year, but that relative difference is essentially always the same. Of course, things like topography, elevation, soil texture, they really don't change unless you start physically moving soil around. we always say that there's two. I mean, what we're really talking about here is managing field variability using variable rate technology. This technology exists on most, if not all, new equipment nowadays, and much used equipment, and is used in a lot of different crops around the world now. And there can be a lot of benefits, both economical, environmental, you name it. But regardless of what you're applying and even how you're applying it, we always see there's two fundamental things you really have to get right for this to be successful. And when I mean be successful, I mean provide an ROI at the farm level, to the farm. Okay. And the number one thing is you got to get the management zones right, which means you have to group areas together that have similar response characteristics for the treatment you're talking about. Now, if we're talking about, say, sulfur responsiveness, we want to get zones that sort of determine where the most responsive soils to sulfur are and where the least responsive soils to sulfur are, and maybe some gradient in between. If it's a fungicide, for example, it might simply be something as simple as an on-off, where there's very, very poor crop or no crop that doesn't justify a fungicide versus good crop that does need a fungicide. So it all depends. Once you have the right management zones, you always have to get the agronomy right. And this isn't always simple. There's not necessarily a right and wrong answer. But, at the end of the day, the goal is to apply proper agronomy in each area of the field for both short-term and in some cases long-term ROI is considered too. What's interesting is, on the right, it's an excerpt from the Alberta Soil Fertility Manual, I believe, and you'll see at the bottom that the source is from Westco Fertilizers, which is long gone many years ago. But this document is actually about 30 years old. But I came across it one day about a year ago and thought, it's interesting because the concept of SWAT maps really has been known or talked about for quite some time. And this is really what we're doing, is trying to delineate these different areas of a field into different soil types, really. And in this case, in this example, they're giving an area of a saline area and then sort of an average area and then a sandy ridge going through that field. And in the Western Canadian landscape, we map a lot of fields that actually look just like this or something similar. So, and I always say again, if we're applying inputs to the soil, which is what we primarily use SWAT maps for, we should really be starting with management zones based on the soil, right? So what should fertility management zones be based on? Well, in our opinion, the soil, water, and topography. And these are all interrelated to some degree. Soil, when we talk about soil, we're talking about, topsoil depth, organic matter content, probably not so much in potato ground, but things like salinity and solonetzic soils. Texture is a major driver of responsiveness to certain soils like potassium and things that are really strongly related to sand content. And you need to think in 3D, right? It's how deep is that A horizon, for instance? How deep is the organic matter? Water is undoubtedly the biggest factor in crop variability. It doesn't matter what crop you're talking about. And then actually in many landscapes in Western Canada, we can lose yield to too much or too little water, all in the same field, all in the same year. Water is a major, major driver on nutrient movement and accumulation in certain areas, depending on where it's water shedding and where is water collecting, and in some cases eroding actual physical soil with that too, and taking nutrients with it. And topography drives a lot of that, and not elevation, but topography, and those are very two different things that often are used interchangeably, and they really shouldn't be. Topography is what drives water accumulation and shedding. So how do we do this? Well, it's a bit of a process, but to put it very quickly, what we typically would do would be go out simply in a half-ton truck, and we have this thing in the back that's called a SWAT box. Within that SWAT box is a device that measures electrical conductivity. So it might be an EM38, which is a device that's actually been around a very, very long time in Canada. or in some cases it might be a topsoil mapper. But either way, it's measuring the electrical conductivity of the soil at a couple different depths, which is related to solutes in the soil, it's related to moisture, it's related to texture, which again are somewhat all interrelated with each other. But at the end of the day, it's a really good tool for delineating salt gradients and soil texture. We also collect elevation data, very accurate RTK elevations. We either collect it at the time in the field or can get it through LiDAR or other sources. And we create topography and water flow and accumulation models from that can also go into the final SWAT map. So the final SWAT map can be a combination of multiple layers that ultimately the goal is to depict the dominant variable characteristics in the field. So a good example would be a field with a really quite strong texture gradient, from say a sandy loam or loamy sand all the way to a clay loam, especially if there's a little bit of salinity. EC would be a really, really important layer in that map. On the other hand, a field that's just simply all topography related, which is driving water flow and accumulation, maybe there's very little texture difference. That's where the topography is maybe a more important factor. But SWAT maps allows you to sort of combine different layers to come up with a map that matches the field variability. So here's an example of some base layers from a field just outside of Saskatoon, Saskatchewan, at the Ag and Motion Discovery Farm. This is definitely not potato ground, but just wanted to use it as an example. So here's the electrical conductivity layer. So the on the left, so the red areas are actually really low, definitely not saline. All the salts are leaching through, and all the solutes, so mobile nutrients, sulfate, chloride, all those sort of things really leach right through. On the other hand, the high EC areas in this particular field are actually saline. So they grow very little crop, actually on the verge of being solenetzic as well, with a little bit higher sodium. So very poor soils. In the middle, you'll see an elevation and actually a water flow and accumulation layer there that we can utilize for the maps. And then beside it, the topography layer. So you'll see, again, they're very, very different. And topography and elevation should not be, used interchangeably. So the final product on the right-hand side there is the SWAT map, which in this case, in this field, is actually a combination of the EC data, the electrical conductivity data, and the topography layer. Okay. So generally speaking, those red areas are dry, they're sandier, whereas the darkest green areas, which we call a zone 10, are the wettest areas, and in this particular field happen to be saline. So a SWAT map is actually different for every field. A zone 10 in one field is not the same as a zone 10 in another field, but it's just a general framework. And I always say the best way to think about it is really in the context of water, because your zone 1 should generally be always the driest, zone 10 the wettest. Here's an example. We happen to have some really good pictures. We did some very deep cores to install water probes in this particular field, actually in 3 different zones. So yeah, you'll see the sand content is quite high in this zone 1 in this case, especially in the subsoil. And then as we generally go down through the SWAT zones, this is zone 8, not zone 10, but in zone 8 already the clay content is quite higher. You can see darker soil, wetter at the time of sampling. So quite a bit different. And just an example here of a soil test. This test happens to be from northern Alberta, so probably a little more variation in organic matter, for instance, than what most potato growing regions would see. But although we do have a lot of seed potato fields in this area, in the Edmonton area specifically, and this would actually be quite typical, I would think, on some of those. So a good portion of this field actually has quite a nice, well-drained, sandy loam soil, much lower organic matter. You can see a very, very wide range of organic matter, big range of pH, very, very common in this higher rainfall area. what we see is these sandier loams that are have less organic matter, just simply have less buffering capacity to resist the acidification of the soil over time. So that's really common. Anyway, typical gradient for sulfur, from actually quite deficient to really excess salts accumulating in some of these high organic matter wet depressions. So yeah, just a good example. The real power and value behind SWAT maps in a lot of fields would be really the ability to interpret and predict better nutrient availability and mineralization, and therefore nutrient response in different parts of the field. So in this part of the world here, we get these high organic matter depressions that can supply a lot of nutrients, and in particular nitrogen. They're just really, really always mineralizing a lot of nutrients, and we can actually afford to cut back, even though they still have really good yield potential. You don't necessarily need to really put on a lot of fertilizer in those places. So that's just a quick example. I'm sure Evan will share much better examples, better related to some potato growing soils. So I'm happy to hand it over to him.
Thanks, Wes. Remember, if you have any questions for the presenters, please type these into the chat box at any time during the webinar, and we'll address them during the question and answer session after the presentations. Also, if you're having any trouble with the audio cutting out, please press reconnect, and you should be able to reconnect right away. And I'll remind you that if you do miss any parts of this webinar presentation, we will have a live recording recording available of the live presentation shortly afterwards that you can watch to check on any spots that you missed. Our next presenter is Evan MacDonald, who works as a precision agriculture specialist with Cavendish Agri-Services in Prince Edward Island. Evan previously worked as a soil and water conservation specialist with the PEI Department of Agriculture, where he helped growers prevent soil erosion issues on their fields by mapping and managing topographic differences. Integrating SWAT maps as a precision ag service offering was a natural fit, as he has become very familiar with the impacts the differences in the landscape have on crop protection and managing yield potential, specifically in potatoes. Evan graduated with a bachelor's degree in geography from St. Mary's University in 2010, a diploma in advanced geographic sciences from the Center of Geographic Sciences in 2011, and a master's of science degree in environmental science from the University of Prince Edward Island in 2018, where his thesis project focused on the use of aerial imagery captured by UAVs in predicting potato yield early in the season. Take it away, please, Evan.
Thanks a lot, Ashley, and thanks for having me today. Wes provided a great background there on SWAT maps, and he's been working with this technology longer than I have, and I think the good thing about the principles behind SWAT, soil, water, and topography, is that they really can apply pretty much anywhere. So I'll kind of dial it in a little bit towards potato production here. I don't claim to be a fertility specialist or anything like that. I'm trying to learn as much as I can every year going forward. And, potatoes are a very complex crop to grow. So I think in order to be considered an expert in this field, you have to be doing this stuff for a really long time. So I'll just bring a few different ways, I guess, of thinking about our fields and how we might look at doing variable rate using SWAT. So as far as precision ag and potatoes goes, I think they're a prime candidate for doing a lot of this work. They're a really expensive crop to grow, over $3,000 an acre. They require a lot of inputs. So even marginal gains or marginal savings in fertility, or, small gains in yield can add up to a lot in something like potatoes. Whereas, if it's a lesser value crop, those 10% and 5% don't mean as much. But when you're dealing with something that costs $3,000 an acre to grow or more, it can really add up. So a lot of growers already do things like grid sampling for variable rate fertility prescriptions, which I think is great. I think anytime you can take into account the differences in your field and try and manage them, I think it's a good thing, and I think it has a lot of positive benefits. But SWAT can really help to target those prescriptions by managing those differences in soil, water, and topography. And when I think about precision ag and potatoes, I think one of the places in the world that's probably ahead of the curve a little bit was probably in Holland. They do a lot of variable rate, things with planting and fertility there already. And a lot of that is based on electrical conductivity. So Wes did a good job describing, what EC is actually measuring in the field. And in their landscape where it's very flat, EC works well. They don't have a lot of topographic variability like we do here. Our landscape is quite rolling here. A lot of elevation changes. We don't have the mountains in this area, but the fields are really quite variable, and a lot of that is due to the topography differences. And in potatoes, this production system, soil erosion can be an issue with tillage and with a lot of bare soil at certain times of the year. All you have to do though around here now is take a drive along the countryside, and really you notice how good of a job and how serious farmers are actually taking that now. You see a lot of cover crops, a lot of fields now that are green that maybe if you did that same drive 10 years ago, they would have been bare. A lot more conservation tillage and things like soil conservation structures in place. Preventing soil erosion going forward is very important, but managing your fields based on, how soil moved in the past is also, I think, can have a positive impact. It's really hard to change, what happened in the past. If soil moved around a lot, left the field, it's not easy to build that topsoil back. So kind of using SWAT to figure out which parts of the field soil may have left from, where it deposited, where the differences and maybe yield potential are on the field. I think all that can be done with SWAT. So this is just an example of about a 1 acre section of land here. I think this was a bean stubble. Actually, this is actually a photo from a 3D model captured with a drone. There's about 50 tons of topsoil lost on that 1 acre section of land with that, rill and gully erosion, which in the springtime after the snow melts here, that's not totally uncommon. So if there was no erosion going forward, it would take nearly 20 years to get that topsoil back. So just to give you an idea how long it does take to get it back, and that's probably an optimistic look at it. I've heard other views say it takes 100 to 500 years to grow an inch of topsoil. And then in addition to that, scientists in the States from the University of Wisconsin saying that it costs the fertilizer value in a ton of topsoil is about $13 a ton. So we often think of soil erosion as an environmental issue, but really it's definitely an economic issue too. And with soil leaving the field or leaving even the place that it was in the field, production's going with that as well. So it's great to see that farmers are really taking this stuff seriously around here now and doing a good job of mitigating it in the future. I'll just talk a little bit about some comparisons between grid sampling and SWAT here. This is kind of around here, a 25 acre field is typical. So about 10 samples on that field, if you were doing a 2.5 acre grid, would be normal. So, you have your grid drawn on there, and your sample points generally are coming from the center of those grid. So this next slide, though, will show differences in topography on that field, which is also quite typical in this area. So hilltops showing up in red, depressions and water collecting areas in the darker blue. So even within one grid cell, you have quite a bit of variability there. It's really not possible to capture that with just a straight grid sample from the center. But with SWAT maps, we try and capture that and represent that a little bit in the prescription, which I can chat about here later on in this presentation. And then I just, for context, drew on what a typical spreader application width for something like granular ability that's there. I'll tell a little bit of a story here through some imagery, I think, and how SWAT can kind of measure some of these differences that we're seeing in a couple of these pictures here. So this satellite image was from July 2017. You'll see in the center there, I believe this was a barley crop at this point. You'll see in the center of the image there a kind of weaker, poor performing part of that field. In the next picture here, July 2019, In potatoes, it's actually being irrigated. It looks like at the time of this picture, you can see the pivot moving there. But the weaker performing parts of the field are just down the slope a little bit there. You'll see some kind of bare patches to the right of the center of the image. So the imagery doesn't really tell us why those were poorly performing, but we SWAT mapped that field this fall, and using EC found a lot of differences there. So the spot that showed up really poorly in 2017, kind of in this dark area in the middle, was a steeper slope, 4 or 5%. Likely had a history of erosion, a very thin layer of topsoil, and actually down underneath we dug a pit there and found a layer of hard sandstone about 14 inches down from the surface. So, and then down the hill, those areas that were showing up with a really high EC value were wet, poorly drained depressions. There were heavy soil in there. I would have certainly got my truck stuck if I tried to drive through there. So quite different areas, and they were really only 100 to a couple hundred feet apart. So in 2017, anyone listening here from this region will remember, well, the last 4 or 5 years have been quite similar, but 2017 started off very dry. And in July there, that barley crop really was struggling on that ridge, that sandy ridge with thin topsoil and, a layer of sandstone not too far from the surface. So if that was a potato year, not a lot of room for the roots to go down after that ridge is formed. They're a shallower rooted crop anyway, but still, even with irrigation, I think they probably wouldn't be an optimal part of that field in terms of yield potential for sure. And then in 2019, folks will remember here, it was actually a wet spring. So those areas of the field that were showing up kind of bare on that satellite image was likely due to the fact that those parts didn't get planted. Those really wet parts of the field would have been a challenge to get through in the springtime. So really what these pictures tell us is that, management zones built from imagery or yield data don't necessarily work that well because they're not telling us why an area isn't performing well. If we said we're going to make a variable rate planting map based on the last 3 years of yield, well, you're going to have probably average readings for some of those places that when really they're, in most cases, they could be, if it's a wet or a dry year, they're going to be lower productive areas. So with SWAT maps, we can really address that variability that we're measuring. So how do we use that? It's not just pretty colored maps. No one really wants to pay for that. You got to be able to do something with it, right? So ground truthing and soil sampling is always part of the SWAT maps process. And zone or grid sampling can be used in conjunction with the SWAT zones to build prescriptions. So, some of the common ones for fertility for things like potash and mag and lime being spread. Even had a lot of interest in doing things like manure and soil amendment applications, targeting certain parts of the field that may need that a little bit more than others. So, maybe you pounded on some of those eroded knolls and back off a little bit in those depression areas that have been collecting moisture over time. So variable rate planting, I think, has a lot of promise. A lot of growers have the capability on their planters to adjust the spacing, and a good base of information is, a SWAT map would be a great base for making those decisions. Seeding other crops in the rotation, as you've seen, it's not just meant for potatoes. It can be used for, the other crops in the rotation as well. Soil applied herbicide is something that's being used out west a little bit. So if we're finding parts of the field that have consistent weed pressure, that would be a good use as well. And then in the future, things like irrigation. So those factors that go into building SWAT will greatly determine, the moisture variability through the field. And things like if we're going to, do an in-season application of nitrogen, it's nice to know which parts of the field will have a little better ability to take up that extra fertility. And then identifying areas of the field that may be better left off out of production, save money on planting and inputs and things like that. I'll just show an example of how an actual prescription file might look based on grid or based on SWAT, and just show a little bit of the differences. So this is just showing a field that was sampled using the SWAT method. So you see some samples from the hilltops, some from the lower areas. Not a ton of variability in terms of potash availability in the soil there, but a grid prescription is going to take those low values and try and apply more potash in those areas, which makes sense, right? You're trying to build it up in those areas, but what it's not measuring is, what are the actual differences in the field? What are the differences in the soil texture and the ability to actually hold on to nutrients and moisture and things like that? So if we look at it here on the grid version, it's taking the lower ppm values of potash and trying to put, over 400 pounds on there, even up on that hilltop. Whereas with the SWAT prescription, we can kind of take and target that a little bit more and say, well, maybe we'll back off on that knoll because we know there's a thin layer of topsoil there, likely less moisture availability and less availability for the crop to take that up, and maybe go a little less up there and try and really just optimize the distribution of that potash prescription across the field. And I just have a little blurb on the bottom left corner there. It's probably hard to see just from the University of Minnesota extension, that, higher soil moisture usually means greater K availability for the crop. So I think it makes sense to try and target our prescriptions a little bit like this when we have that background of information to know where those differences are in the field. When we're doing variable rate, we're oftentimes accounting for the differences in potash or the differences in mag or whatever it is, but we're not really accounting for the differences in how likely is the crop to be able to take that up. So with SWAT maps, we can do that where, it's a little different than grid sampling where we're not actually able to measure any of those things. So in terms of, how does SWAT zone impact crop production? And, this is just one example here that I think you could probably scale this across thousands and thousands of acres in this region in the last few summers. But you look up on that zone 1 on that knoll, a little bit of erosion history there, a thinner layer of topsoil. Early on in the season, you'll see in the lower left, down in the zones 9 and 10, those areas were nearing row closure in the second week of July. And up on the hilltop, they weren't even close. And those were only, 150 feet apart. And the spots on the top of the hill, they never ever closed over. And you see kind of some of the root mass and, tuber initiation there that was going on in the zone 9 and 10 area where it wasn't at all in the zone 1. And then that just followed through right till the end of the year where there was a 30% difference in yield between those two zones that were 100 feet apart. So in a year that we had basically no rain in that region, the field was planted the same, the field was fertilized the same. We see a 30% difference in yield. And what was the factor that, made that difference? Really, it was in the soil. It was in the ability for that soil in that lower landscape position to hold on to whatever moisture was there and hold on to the nutrients a little better than that zone that was a little further up the hill on the knoll. So maybe we should be thinking about, fertilizing these areas a little bit differently and, planting them a little bit differently when we go down the road of variable rate planting. Can we get a little bit more out of those lower areas? And can we maybe mitigate our risk a little bit on those hilltops? Maybe there's things we can do to try and remedy them, but a lot of times it's hard to fix that stuff. That's a long-term game in those areas. So, a lot of farms don't have the ability to irrigate right now in this area in particular, but I think every farm has the ability to try and address that variability that's there in the field. And I think, a strategy like this, especially over the last few years, would work quite well. Really, I think as farmers, you really only have probably 30 to 40 cracks at it. So I think waiting for some type of a perfect solution to come along that's going to save the day is not really that realistic. I think we just have to try and, do a little bit better than average each year and maybe think a little bit differently about those differences in the field and try a few new things here and there. And I think, small incremental changes year over year can make a difference over time. We see, 1,000 acres, well over $500,000 on fertility and seed and things like that. So, I think investing a little bit of money and understanding the differences in your field and really measuring that soil and trying to get the best fertility and seed prescription that you can. Kind of makes sense. So I don't have anything else to add here. Sorry about my voice. Kids in daycare is bringing home colds. It's that time of year. So thanks a lot, and I'm happy to take any questions.
Thanks so much, Evan. Okay, so now I'd like to do a short question and answer session. I know some of you already put some questions in, but if you haven't yet, please make sure to type it in and we will into the chat box and we will get around to answering it. Our first question is from Ryan Barrett, and he's asking, Evan, how many zones do you end up using for VR fertility with growers?
Hey, Ryan. Usually it comes down to sometimes combining some of those. So SWAT zones basically are always made with 10 zones. And I know a lot of people maybe think that whatever that's overkill. But it's better to start with too many zones and then combine afterwards than try and start with too little and try and make more later. So a lot of times what we do is, a 1 and a 2 are combined together, and a 9 and a 10 are combined together. But it just kind of depends on the field, Ryan. There's a lot of differences. Like some fields have a lot of zone 10s that are actual water holding depressions. Sometimes the zone 10s may have been more areas that have experienced deposition, or their runs with erosion that probably should be a grass waterway. So it all just kind of depends on the field, but a lot of times we're going with in that 5 area, something like that.
Thanks so much. Okay, so our next question is from, I'm going to apologize now for butchering the pronunciation of this name, Florian Diker. Where do you see the highest ROI?
I might let Wes take this one over, just because I think there's potential for higher ROI in really trying to take advantage of those more optimal parts of the field in potatoes. But really, this is the first year we've done it. We don't have a lot of data from this particular region in potatoes this year. But if Wes is able to address that one, I'll let him take that one over.
All right. Yeah. I'm going to give such an agronomist answer, and the answer no farmer wants to hear, but I'm going to say it depends. It's the right answer, frankly. Every field can be so different. I deal with really almost every other crop but potatoes. But with small grains, for instance, a lot of acres I deal directly with are in northern Alberta, for instance. We can get some significant ROI from even just managing soil copper levels and nitrogen. So lodging in wheat, for example, is a common issue in certain parts of the landscape for us. So, we can really manage lodging really well and address some of those more expensive nutrients like micronutrients in very specific parts of the field. So traditionally they'd be applying it on, blanket application, maybe $10 an acre worth of copper over the whole field. And now we're really only treating 15% of the field, right? So we're truly actually saving money in an example like that. But again, sometimes there's an opportunity to isolate areas that are nutrient limited, because with SWAT maps, we have the ability to understand relative water differences. So you can start to isolate, well, are we losing yield because of just drought, or is it actually nutrient limited? Is it limited because of pH? Like, we're finding a lot of that. And that, I think, is really could be applied in all crops anywhere, but it really depends what kind of soils and landscape you're in is what's going to be the factors that are affecting yield. So
thanks so much, Evan. Our next question is from Marlene Clark, and I think this one's for thanks so much, Wes. I was thinking the next question is for Evan. So do our PEI farmers have the ability to put their fertilizer on per the prescription for variability?
Yes, they do. And it kind of depends on the products, I guess. A lot of the fertility is done at planting. So, down the tubes, where we're a little more limited there. But I think with some of these more variable rate planter capabilities and abilities to adjust spacings and things like that, we'll be able to do a little bit more there. And then, lime, potash, mag, K-mag, things like that are all currently being done. They've been done the past past while with things based off, grid sampling. So there's really no difference in terms of what you can use grid sampling for than what you can use SWAT maps for. They can do the same things. It's just a little bit different sampling strategy, and the zones will look a little different. And then in the future, I think, looking at doing things like spoon feeding the crop a little bit in season, whether that's with nitrogen or something like that, but targeting certain areas of the field where we think there's a little more likelihood that the crop will be able to take that product up. I think that has a lot of potential too. So that's something we're going to be looking at this year too.
Thank you, Evan. Our next question is from, and I'm going to apologize now for mispronouncing this name, Soren Overgaard Schipper. Do you have any proof of yield maps that show correlation between prediction of high/low yield areas predicted by SWAT maps?
Well, I'll touch on that one a bit, and maybe Wes can add later, but SWAT maps aren't meant to be directly just yield potential maps. I think in a lot of cases, they turn out to be kind of that way, especially around here the last few years, but they're more meant to be, fertility response zones instead of yield potential zones. But from what I've seen the last few years here, and when I look at fields, and even without even having a SWAT mapping done on them, and just looking at the topography, you can clearly see it. If you look at satellite imagery, that will show it. Even early season NDVI does a pretty good job of predicting what that yield's going to be like at the end of the season. And I've seen that in almost every field we SWAT mapped here this year. Did quite a few 10-foot strips in a lot of these different areas and found it. And I think if you talk to a farmer who was going along in the harvester or in the windrower or even driving the truck, they're gonna see the differences pretty evident when you go over a knoll that didn't have a whole lot of topsoil there. It's quite a thinner crop in those parts of the field. So they're not meant to be kind of yield potential maps. In a lot of cases I find they are, but it's more about getting that fertility response and finding out where the similarities are.
Yeah, that's good comment, Evan. I would echo that. It's you're bang on. I mean, yield is really a dynamic thing that can vary year to year depending on rainfall, frankly. So it's, the yields don't necessarily have a linear correlation to the SWAT zones. Sometimes they do. So for example, in this past year, Northern Alberta, we were extremely wet. And so zone 1, typically the driest zone, rarely the highest yielding, was actually the highest yielding zone in the bulk of my clients' fields, where zone 10's actually really zone 7 through 10 were completely flooded out. So whereas traditionally zone 7 and 8 would actually be a really high yielding zone. So again, it does really depend on the area, depends on the rainfall, depends on the field, and depends on the factors affecting yield. So I have an example that I guess wasn't in my presentation, but actually that field from the Ag and Motion Discovery Farm, I quite accurately predicted the yield by zone, in just sort of understanding what the limitations in each zone would be. I think I was within 5 or 10 bushels of wheat in that case. So it's a lot of the time you can have a pretty good understanding of what to expect from yield.
Thank you, Wes and Evan. Okay, our next question is from Grant McMillan, and this one's for Evan. Since Zone 1 areas are poor production areas, have you ever made any recommendations to growers to not plant those areas and save money on production costs?
Well, Wes kind of gave a good example there. If we ever did have a wet year, which we haven't had one here in a while, but maybe those Zone 1s wouldn't do too badly. I think it comes down to, not all Zone 1s are created equal. I think if it's a field where that's had a particularly hard time with erosion, even in a wet year, and I've seen it on irrigated fields, there's differences in those Zone 1s to the lower areas, like the areas that just have that thin layer of topsoil and not a whole lot of ability to hold on to any nutrients or moisture. They do seem to struggle a little bit more. So I think in some cases we need to consider things like that. In some places you already see it, where knolls or really high sloped areas that were almost scalped of topsoil, they're just not planted anymore. So I think there's probably potential there to look at doing things like using soil building crops in those areas. Have I made those recommendations to any growers yet? Not yet. I think it's the first year and we're just kind of getting into it. But I think in the future, those are definitely going to be conversations that'll happen. How can we improve some of those areas? Maybe we take them out of the potato rotation once and kind of leave a soil building crop in certain parts of the field where maybe the farmer's just losing money on year after year anyway. I think they're hard conversations to have, but at the end of the day, it comes down to the bottom line, right? So if you're going to spend $3,000 to make 1,000, then it doesn't make a lot of sense.
Evan, Wes, would you like to add anything to that since you've been working with SWAT Maps for so long?
Yeah, I would echo Evan's comments. It really depends. I work primarily with dry land, and that's a distinct difference I think we can make, because with irrigation, when you can control water, some of those poorer areas with often less topsoil, for example, and that's a good example of a lot of zone ones in Western Canada as well. They might actually, if we can control the water and get enough water to them, they might actually just need more fertilizer and be able to actually be improved significantly, or maybe compost or manure or something like that, right? So I do that with a lot of my clients currently, and it's definitely working. But you've got to have, the rainfall environment or controlled rainfall, so to speak, to do that.
Thank you so much. Our next question is from Colby Robertson, and I'm guessing this one will be for Evan. Does the EC of potato tubers differ enough from the surrounding soil that EM38 could be used for checking below ground yield near the end of the growing season?
That's an interesting one. I haven't driven over an actual potato field with the SWAT box yet, but if there's any farmers that want to let me try, then maybe we'll give it a go next year before harvest. I didn't want to damage any tops or anything like that, but who knows, Colby? That might be another application for us.
Thanks so much. And we have another question from Soren. We have another question from Florian first. When does it make more sense to abandon acres instead of trying to even out a field? Variable rate technology needs a lot of attention and can be fairly costly, especially for irrigation.
Yep, I think that's a good point. I think we kind of touched on it on the last few answers, but if there are parts of the field that just year after year aren't performing, then when do you finally cut the cord, or when do you try and abandon it, maybe even temporarily? And it sounds like Wes has some experience in looking into those different zones within a field, so maybe he can provide some more context there. But I think at the end of the day, you look at how much money are you making in those areas, how much money are you spending, and that can be one of the real simple applications for precision ag, is just finding which parts of the farm maybe should you leave off a little bit.
Yeah, I guess if I think of a southern Alberta irrigated potato area, for instance, it wouldn't be uncommon to have some lower elevation corner where often heavier texture and maybe some salts are accumulating down slope, right? Well, maybe you cut that out, and you don't even, because a problem like salinity or higher sodium solonetic type soils, like you're just never gonna, it's a water problem, right? Unless you start tiling and improving drainage and doing all sorts of stuff, they're just never going to produce well. So yeah, it's not uncommon for one of my first recommendations to a grower to say, seed this down to grass, like don't farm it, cut your losses. You're going to lose money. So not the answer they want to hear, but again, it's sometimes the right answer.
Thanks so much, Wes and Evan. Our next question is from Soren, and it says, can SWAT maps help to predict / keep track of areas with free living nematodes?
I haven't heard of that at all, so I really can't provide an answer to that. If I did, I'd be lying. So it would be great to be able to come up with a map of the field of where free living nematodes were, but not that I'm aware of. No.
Thank you. And we have one last question, it looks like, unless anyone else wants to get a question in before we wrap up the webinar. We have another question from Soren, and he says, do you recommend to make new SWAT maps every 5 or 10 years?
You shouldn't need to, would be my typical answer. It's again, the SWAT maps are based on really stable attributes of the soil. So unless there's been a lot of, drainage ditches done, earth moving, that sort of thing, like physically changing the landscape, really, there shouldn't really be any need to remap a field. So Crop Pro Consulting has been utilizing SWAT maps for, I think, over 10 years in Saskatchewan, at least anyway. And so a lot of those fields, we're still using the same SWAT map today, and it still reflects the variability, the soil variability in the field.
Yeah, and just to add to that, that's kind of what I expect around here too. Is if those soil properties aren't changing, then we wouldn't need to make a new SWAT map. Really, what the strategy is to have your SWAT map done, and then normally around here the process is, if someone does do soil sampling, usually it's in the year before potatoes, then you keep doing your soil sampling, and you kind of can use your SWAT map to tweak your prescriptions a little bit. So that's kind of the process that I envision happening anyway.
Thanks, Wes and Evan. Okay, well, that's all we have time for today. I'd like to take one more chance to thank our speakers, Wes and Evan, for joining us today. And I would once again like to thank our sponsors, BASF and McCain, for making this webinar possible. And a big thank you goes out to everyone for participating. I hope you have found this information valuable. Again, a recording of this webinar will be made available on spudsmart.com shortly after the conclusion of this event. Thanks again, and we hope you have a wonderful day.